we're going to solve radical equations. In order to solve a radical equation, we need to solve them by isolating the radical terms. Then we'll square both sides of that equation. What this does is, at times, it may create what's called extraneous solutions. Extraneous solutions are problems that appear valid until we go back and check in our original problem, and we'll see that they do not indeed supply a true answer for the real number system. We'll talk about specific examples of that. Let's first look at some simple radical equations. For example, square root of x plus 11 is equal to 21. Alright, our object is to isolate the variable as it is with any algebraic equation. Here our variable happens to be underneath a radical sign. So first we're going to get the radical expression by itself. We're going to subtract 11 from both sides of the equation, and we get radical x is equal to 10. At that point, I don't want to know what radical x is, I want to know what x is. So in order to get rid of the radical expression, I'm going to square it. Because I squared the left-hand side of the equation, I have to square the right-hand side. So I now get x is equal to 100. Let's go back and check our work. Plug in 100 into my original equation and see if it makes a true statement. Square root of 100 is 10. Does 10 plus 11 equal 21? Yes, indeed it does. So we're good to go. Another type of radical equation that you're going to be asked to solve is where we end up with a radical expression on both sides of the equal sign. So something like this. Square root of 3m minus 6 is equal to the square root of m plus 23. We're going to use the same method. I don't want to know the square root of a particular variable. I want to know what the variable itself is worth. And I also need to isolate that variable. So right now, first step is let's get rid of those radical signs. So we're going to square both sides of the equation. That leaves me simply with the radicand. I'm going to then move all constants to the left-hand side. So I'm going to take away an m from both sides. 3m minus m is 2m. And now I'm going to move all constants to the right-hand side. So I'm going to add 6 to both sides. And I get 2m is equal to 20. At this point, I'm going to divide by 2 so I can completely isolate the variable. And I'm left with m is equal to 14 and a half. Okay. If I go back to my original problem and I plug in 14 and a half, if I get 3 times 14 and a half, that's 43 and a half, minus 6 is 37 and a half. So square root of 37 and a half. Does that indeed equal the right-hand side? Plug in 14 and a half. 14 and a half plus 23 is 37 and a half. Yes, they're the exact same expression, and so that checks. And they're both positive expressions under the radical sign. So again, they're valid. We're going to look at a type of problem that we have no solution to. And the reason we would have no solution would be that it doesn't make the original problem true when we go back and check our solution, or in a real number system, what is underneath the radical. The radicand can never be negative in the real number system. So two reasons that we may have no solution. It doesn't check in the original problem, or it creates a negative radicand. So let's take a look at this. This one, if I subtract 7 from both sides of the equation, I'm left with square root of 4r is equal to a negative 4. Here I'm going to stop and say no solution, because I cannot have any expression in here that's going to create a negative answer. And so at this point, I know that for my real number system, I have no solution. Another type of problem that may have no solution, or an extraneous solution, is the type of problem where when we square both sides of the equation, we end up creating a quadratic equation. So let's solve this. 2y is equal to the square root of 5y plus 6. We're going to have a few concepts going on here, so this is a good problem to pick up on a few different tricks. My left-hand side of the equation is fine, but I do not want that radical sign, so I'm going to get rid of it by squaring that expression. Therefore, I have to square the second, or the left-hand side. When I square 2y, I'm not simply squaring the variable, I'm squaring the entire expression. So it's 4y squared is equal to 5y plus 6. I'm now going to move all terms to the left-hand side and set this equation equal to 0 so that I have an easily factored quadratic equation. I'm going to subtract a 5y from both sides. And I get 4y squared minus 5y is equal to 6. And then I'm going to subtract a 6 from both sides. And my new quadratic equation is 4y squared minus 5y minus 6 is equal to 0. Alright, thinking back, when I have a quadratic equation, I ask myself, are there any greatest common factors? Is this easily factored, or do I need to go to the quadratic formula? I see an easily factorable equation, so I'm going to look for factors of negative 24, which is 4 times negative 6. What are my factors of negative 24 that add up to a negative 5? Well, that's negative 8 times 3. Okay, so I'm going to rewrite this quadratic equation as 4y squared minus 8y plus 3y minus 6 is equal to 0. So I've not changed the value at all. I've simply rewritten this middle term with negative 8y plus 3y. I do that because now I have these two groups of terms that have common factors. 4y can be factored out of the first two terms, leaving me with y minus 2. And a 3 can be factored out of the last two terms, leaving me with a y minus 2. So I recognize now a common factor in both of those expressions, and that's the y minus 2. So I'm going to factor that out, And that leaves me with a y minus 2 times a quantity 4y plus 3 equal to 0. So at this point, I know my solutions are y is equal to 2 and y is equal to negative 3/4. I always have to go back and check my work. So I'm going to go back to my original problem, which was 2y is equal to the square root of 5y plus 6, and I'm going to check my two answers that I just had, which were 2 and negative 3/4. I'm going to check 2 and I'm going to check negative 3/4. If I plug 2 into this original problem, I get 2 times 2 is equal to the square root of 5 times 2 plus 6. Is 4 equal to the square root of 16? Yes, it is. So 2 is a solution. Then I'll go and I'll check the negative 3/4. 2 times negative 3/4, is that equal to 5 times negative 3/4 plus 6? Okay, right here I see that I'm going to have a negative 6/4. I have a negative answer being equal to a radical expression. At this point, I can say this is extraneous because I cannot have a negative answer to a radical expression, not in the real number system.